That pretty much explains what I'm doing now, because I was very connected to nature, less so to people. So I don't have any footprint on social media. I don't care how many likes I get on Twitter. What I care about is understanding the reality that we live in. And every morning I jog at 5 a.m. in the company of birds, ducks, bunnies, wild turkeys. And I really enjoy nature left to itself. And, you know, the biggest volume of nature is actually out there. You know, we tend to focus on the two-dimensional surface of the Earth. You know, if you open the morning news, it's all about what happens on this planet. But there is a third dimension, looking up. And actually, the universe is too big for us to ignore it. So I'm very fortunate to actually enjoy what I'm doing right now, even though, you know, it was a forced marriage. It was sort of an arranged marriage, I should say, because I was interested in philosophy, and then I had to serve in the military. That's obligatory in Israel, but I selected physics as a compromise. It's still, it involves intellectual work, but, you know, it was not what I was aiming for. But then I ended up as a tenured professor at Harvard. I served for 9 years as the chair of the astronomy department at Harvard, the longest serving chair over the past decade. And in the process of getting there, I realized that I'm actually married to my true love, even though it was an arranged marriage, because there are many fundamental questions that used to belong to philosophy that we can address using the scientific method. And we can talk about some of them, like how did the universe start, what was there before the Big Bang. But the one that concerns me the most right now is, are we alone? Is there a neighbor that is smarter than we are, or perhaps that existed before us? Because that would offer the opportunity to learn from that neighbor. You know, I have no problem looking over the shoulder of a smarter classmate in trying to figure out the answer to fundamental questions to which we don't have an answer. And it will save us a lot of years. And also, if we find a gadget that was generated by a more advanced technological civilization, you know, like iPhone 100, version 100, you know, that would be fun, because first we need to figure out what it does. And second, there would be lots of people in Silicon Valley interested in cashing on it. So I'm saying it's an opportunity for us to leap forward. And we, you know, it's a mistake on our behalf to basically think that we are the smartest that ever existed, that Albert Einstein is the smartest scientist who ever lived since the Big Bang, 13.8 billion years ago. It's very likely there was a smarter scientist on an exoplanet a billion years ago. And those civilizations who benefited from smarter scientists could have sent equipment to space that we can find.
Isn't it an amazing thought to think about somebody a billion years ago on a different planet who was having, you know, not just scientific endeavors, but also love and just living their life, or just even just picking their nose or something, you know? And do you believe it's possible?
Well, you know, I spoke with the curator of the Museum of Modern Art in New York City, and I told her, her last name is Antonelli, I told her that if we find a gadget that represents our future from another civilization, I'll be glad to put it on exhibit in MoMA, in the Museum of Modern Art, because for us it would represent modernity. Even though for the senders, it would be ancient history. So the one thing to realize is the universe existed for 13.8 billion years, okay? And most stars formed earlier than the sun. So they predated the sun by billions of years. So if you imagine the same clock ticking elsewhere on near another star, you know, they could have predated us by a billion years. That's a long time. During that time, you can pretty much fill up the Milky Way galaxy with probes that move with chemical propulsion, like we sent out of the solar system. You know, we sent 5 probes, Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. They're leaving the solar system just over the past half century. That's what we did. And imagine if we were to continue doing that for millions of years, you know, like, so it's possible the Milky Way galaxy is full of these probes. And just to give you a sense, only over the past decade, astronomers started finding objects that came from outside the solar system, only over the past decade. And by now, there are, as of yesterday, there are 4 of them. 2 of them I discovered with my student, Amir Siraj at Harvard. They were the first interstellar meteors, one discovered in 2014 and the other one in 2017. The third one is called Oumuamua. We can talk about it. I have a book called Extra-terrestrial dedicated to that one. And the fourth one is called Borisov, after the amateur astronomer who discovered it. And the fourth one is the only one that looks familiar. You know, it's like having guests for dinner, and out of the 4 that you get, only one appears familiar, someone that you can really associate with things you've seen before, like icy rocks we have seen in the solar system. The first 3 are really strange. Like the meteors are tougher than any meteor we had seen. So there is a catalog of meteors having 273 objects in it. A meteor, just to explain, a meteor is an object that the Earth collides with. So the Earth moves around the sun, and every now and then it collides with an object that crosses its path by chance, just like a fishing net collecting objects. And that's called a meteor because such an object usually burns up in the atmosphere as a result of the friction with the air. So the US government has sensors that monitor the atmosphere for ballistic missiles. Okay, they want to, as a matter of national security, they want to know about objects entering in the direction of the US, right? So every now and then they see an object that comes from space. And they put it in a they say, well, that's not a risk for us. It just came from space. They put it in a catalog that is publicly available. It's called the CNEOS. Over the past decade, they had 273 objects there. So I was interviewed for a radio station one day in 2019 and then about a meteor, and I went online, I saw this catalog, and I told my student, why don't we check the fastest moving ones and see if they came into the solar system from outside the solar system? There is a very simple way to tell. If they move too fast, they are not bound to the sun. Gravity is not strong enough to keep them in the solar system. So we actually found that meteor from January 8th, 2014, that was moving at 60 kilometers per second outside the solar system, very fast. And it was moving faster than 95% of all the stars in the vicinity of the sun, relative to the sun. Wow. So we said, okay, well, that object is the first object. It's from 2014, the first one from outside the solar system. And then our colleagues were saying, you know, we don't believe the US government. We want proof that this is indeed. So then in March this year, 2022, a few years later, the US Space Command released a letter saying that they confirm our finding that this meteor indeed came from outside the solar system at the 99.999% confidence. And at that point, you know, our paper was accepted for publication 3 years too late. And we started to design an expedition. I got $1.5 million as of 2 weeks ago to go on an expedition to collect the fragments of this meteor. Why? Because not only it was moving very fast, but from the government data that was released this year, together with the letter, we were able to infer that the meteor burned up only in the lower atmosphere of the Earth, and therefore it had a very tough material composition. It was the material strength actually was the highest among all the meteors in the catalog. So it's tougher than 99.7% of all meteors, tougher than iron. And just because it disintegrated only at the lower atmosphere where the stress was enormous, so we can tell the material strength was quite high. And the question is, what is it? And there are two possibilities. It's clear that it's an outlier. It doesn't belong to the type of rocks that you see in the solar system because it's so tough, you know. The question is, does it originate from a very unusual natural source? Or maybe it's a spacecraft. Maybe it's made of an alloy that is artificially made to sustain the extreme stress of the atmosphere. So the only way to find out is to go there, collect the fragments, and figure out what it's made of. That's the way science is done. And what I see some people doing is saying, oh, it's a waste of time, it's a waste of money, why should we care about this rock? And I say, it's a very unusual rock. It's the first one that humanity spotted coming from outside the solar system. And it was moving faster than 95% of the stars. And it was tougher than all the other objects that we know about.
But it has disintegrated a bit, right?
Yeah. So it disintegrated 18.7 kilometers above the ocean surface, about 100 miles off the coast of Papua New Guinea. So the point is,
no good for a spacecraft, is it?
No. So it was probably not operational. That's my guess. Just think about our New Horizons spacecraft. Okay, we launched it a decade and a half ago towards Pluto, and it's making its way out of the solar system now. Okay, just imagine 1 billion years from now, New Horizons colliding with an exoplanet. And the exoscientists on that planet say, oh, look at this meteor burning up in our atmosphere. And then imagine one of them saying, well, let's raise some funds to go on an expedition and check the fragments because it came from outside of our planetary system. So people say, oh, why do we need to do that? We know about the rocks in our planet. But he says, that person says, no, I want to check it out. Then he goes there, scoops the ocean floor, and figures out that it's made of an alloy that nature doesn't put together. And moreover, on New Horizons, there was a small box that was attached to it that carried 30 grams of the ashes of Clyde Tombaugh, the scientist who discovered Pluto. So now just think about it. Those exoscientists, realizing that humans destroyed the genetic information about a scientist they wanted to commemorate. That makes no sense. Like, why would you burn up the DNA of a person you want to celebrate? So they would say this society that sent this spacecraft, they're not very intelligent. They're very aggressive. They have these rituals of destroying the information about the person they want to commemorate. We don't want anything to do with them.
Yeah, that's pretty insane as a thought. I suppose for anybody who's new to like the alien discussion or the extraterrestrial discussion, you probably maybe have to explain the Fermi Paradox. Is that what it was called, the Fermi Paradox?
Yeah, so about 70 years ago, Enrico Fermi, a very distinguished physicist who won the Nobel Prize, for a mistake, by the way, what he was awarded the Nobel Prize for turned out to be wrong, but he did so many important things. Among them, he was part of the Manhattan Project. He built the first nuclear reactor at the University of Chicago. It's still there. At any event, he was at Los Alamos, obviously, Manhattan Project. And he was having lunch with friends, and they were talking about extraterrestrials. And he said, if they are out there, and it's very likely because there are so many stars, billions of stars, where is everybody? He was asking. And that became the Fermi Paradox. Now, just think about it. If you sit at home and you don't see anyone around you, you sit on your sofa, you say, I don't have any neighbors. Where are my neighbors? Well, in order to find your neighbors, you better look through your windows, and you better use a telescope, or you check your backyard whether there are objects that came from the cosmic street. You can't just say, I don't see anyone around me, because he didn't actually use telescopes at the time. And as I said, only over the past decade, we had a survey telescope called Pan-STARRS in Hawaii that discovered Oumuamua. We had those satellites that the US government employs to detect meteors of the type that is cataloged in the CNEOS catalog. So in the days of Fermi, 60 years earlier, there weren't any instruments like that. So obviously, where is everybody? Now, you have to also recognize that, we are talking about billions of years in the context of the universe. So if you're sitting at Los Alamos in 1951 or whatever, and asking this question, it's a very short time span that you are monitoring anything happening around you, okay? Compared to the age of the universe or compared to the ages of stars. So you need the visitors to be there at the time that you're asking the question, which is a very short time span, okay? Yeah. Moreover, space is huge. It's just huge. We are not used to it. But if they sent, for example, small gadgets, you will notice them, because Oumuamua, that was discovered by the Survey Telescope in Hawaii, was the size of a football field. And that's pretty much the smallest size object that we can see the reflection of sunlight from and detect it within the orbit of the Earth around the sun. Okay, so we can't see objects that are the size of a CubeSat that we are sent. The NASA never sent a spacecraft the size of a football field. So we may have been missing objects passing by if they are just space trash, unless they collide with the Earth in the case of a meteor. And moreover, there may be many more small objects compared to big objects. And if they move very fast, we wouldn't know this either. So we are just at the infancy of actually looking for such things. And there was a long history of SETI, the Search for Extraterrestrial Intelligence, that you might be familiar with. It was all guided by the fact that we developed radio communication, and then some astronomers said, okay, well, if we are using radio waves to communicate, maybe, we should search for signals. It sounds like a good idea, but rather narrow-minded, because, we just developed radio communication over the past century, okay? And they probably moved beyond that after 100, 200, 300 years. Like, we already use fiber optics, we use laser communication in space. So my point is, if we don't detect any signals, it doesn't mean much, because perhaps, and also their civilizations may have not lasted very long. But if instead of radio signals, if they sent equipment to space with chemical propulsion, it's still gravitationally bound to the Milky Way. So the Milky Way is like a basket that keeps all the objects moving at tens of kilometers per second bound to it, because it's less than the escape speed. Whereas signals of light escape from the Milky Way. If they were sent 1 billion years ago, they are now 1 billion light years away. They're very far away. We can't see them. So my point is, we can look for the accumulated relics from those civilizations that predated us. And it's just like doing archaeology. I call it interstellar archaeology. Basically, finding evidence for things that existed before us. If you were to, look for radio signal, it's just like saying, I want to have a phone call with Wolfgang Amadeus Mozart. Okay, so it doesn't matter how many numbers you dial on your cell phone, you would never get to Mozart because he's dead. Okay, and the only way to find out about Mozart is to find the musical notes that he wrote, and then you realize that he existed. And in much the same way, us trying to find a radio signal could be misguided, because the civilization that we are trying to communicate with does not exist anymore. And one way to find about it is to find things that it left behind.
I suppose one way that we're trying to find things is through the new James Webb telescope. I've got a question from Ray J in the audience, who's just asking, has the telescope or hasn't the telescope just found something older than the estimated age of the universe?
No. So I was actually on the advisory committee that designed the James Webb Space Telescope. Back then it was called the Next Generation Space Telescope, which I guess would have been in retrospect a better choice. They selected to name it after a NASA administrator because it secured the funding, if you give credit to an early administrator. At any event,
Sure.
This telescope was designed to look at the first stars, the first galaxies, okay? And that means going back to maybe a few 100 million years after the Big Bang, seeing those distant sources that emitted their light when the universe was much younger, about 5% or less of the present age of the universe. That was my main work, actually, early on in my career. There were only a few people interested in the subject at the time that I started, about 3 decades ago. I wrote 2 textbooks about those early galaxies. Now, indeed, the James Webb Space Telescope works fantastically well, okay? So in the first images that it released, there was actually a very deep image of the universe that revealed galaxies that existed hundreds of millions of years after the Big Bang, okay? And we can see the stars emitting light. There is no issue with them being older than the universe. By the way, we can never see something older than the universe. I mean, light is arriving to us from a distance such that, it was emitted at the right time for us to see it now. So if you're looking at very distant sources, they at most can be at a distance that light traversed since the Big Bang. We can't see things that are older than the Big Bang. Okay. And so the issue that was raised about some of these galaxies is that they appear to be very massive. Okay. So people said, oh, these are such massive galaxies, that's in conflict with the popular model of the universe, which is that you start with small building blocks. Galaxies start as dwarf galaxies and then they combine. Think of it as Lego pieces. So you start with a Lego piece that is about 1/1,000,000th of the mass of the Milky Way. And then these Lego pieces come together and build bigger and bigger galaxies. And the surprise is that some of the objects that were seen, some of the galaxies that were seen at early times are relatively big, bigger than expected. And currently there is a discussion about it. It's not resolved yet, but some people suggest that these galaxies were not correctly identified, that in fact they are big because they are closer to us. They, in trying to figure out how far away they are, you have to use what is called the spectrum of a galaxy, basically the distribution of light as a function of wavelength or frequency. And when you try to fit that, you get the so-called cosmological redshift, which gives you a sense of the distance. And the claim is perhaps that was misidentified, that in fact those massive galaxies are closer to us, therefore they are not in conflict with the standard cosmological model. But that is not questioning the light travel. It's just questioning the buildup of structure. So just imagine a situation where suppose galaxies started big, okay? It doesn't violate anything fundamental. It just says that the way we thought about the buildup of structure is wrong. And in fact, I should say that most of the matter in the universe is of a nature that we don't understand. It's called dark matter. That's 80%, 4/5 of the matter in the universe is made of a substance that we don't see in the solar system. It's not what we are made of. Something else, we don't know what it is. For decades, we've been trying to find out. There were billions of dollars invested trying to find evidence for the particles that make up the dark matter. Nothing was found. So we have no clue. And that's one of the puzzles that is not resolved. And in a recent commentary, I said, it's really surprising that we get paid as the people who study the universe, because we don't know what we are talking about. We don't know what most of the matter in the universe is. And and the reason I brought this up actually is because I wrote a paper with a colleague of mine just a week ago about what is astronomy over a period of 10,000 years. We have data over the last century. So just think, if we were to continue this process of collecting data for 10,000 years, 10 millennia, okay? Yeah. What else can we learn? Well, first of all, we would see the universe expanding in real time. We will see things happening. So then I commented that in 10,000 years from now, we scientists, humans, will probably be replaced by AI systems, computers that do the science for us, because they would be smarter. Even within a decade, they might be smarter. AI systems will be sentient eventually and will process data better than humans. So in 10,000 years, it's very likely that it will be AI scientists. And I hope that they will cite my paper about what can you learn in 10,000 years, just to demonstrate that we didn't know what we were talking about when we talked about the dark matter and so forth. But the one thing, that's the future, as long as the legal system will ban us from unplugging sentient computers from the wall, because it would be regarded like murder of humans. If that will be banned, they will rule the world. If, on the other hand, some people will take them out of the outlet, we would rule.
It's a scary thought, the Terminator stuff, I suppose. I mean, I guess we've only got a couple of minutes, but I just made the point, I guess, does it make you sad, I suppose, that so much of this stuff won't be found out until quite some time after both you and I are no longer here?
Oh, no, I don't think so. I think one reason that, for example, we didn't find evidence for gadgets from extraterrestrial civilizations is we didn't search. It's a self-fulfilling prophecy. People often quote Carl Sagan from the 70s saying, extraordinary claims require extraordinary evidence. I say extraordinary evidence requires extraordinary funding. If we were to invest billions of dollars, the same billions of dollars that we invest in the search for dark matter, which has very little significance for most human lives, if we were to invest similar amounts of funds, like at the search for gadgets or equipment or spacecraft sent in our direction into the solar system from other civilizations, we could potentially find it within a decade. It's basically a road that was not taken. Okay, and the advantage of taking the road not taken, that I'm leading the Galileo project, which is aiming to do that. The advantage is that there may be low-hanging fruit. So I would not give up. I would say, let's talk again in a couple of years, because we are collecting data right now. We will go on the expedition near Papua New Guinea. It should be interesting.
Well, let's talk in a couple of years, and hopefully you'll have